The landing deck rushed up too fast. Lieutenant Sam Porter fought the controls of the massive blue fighter as it dropped toward USS Shangri-La like a brick with wings. The Corsair's long nose blocked his view of the deck completely. He was landing blind, trusting instruments and the landing signal officer's frantic paddles. The landing gear caught the deck hard, too hard. The massive fighter bounced 15 feet back into the air, its right wing dipping dangerously. Porter jammed the throttle forward, but the Corsair's torque rolled the aircraft violently left. The wingtips scraped the deck with a shower of sparks. Then the landing gear collapsed. The 20,000-pound fighter slammed onto its belly and skidded toward the island superstructure at 60 miles per hour, trailing flame and torn metal. Deck crews scattered. Porter braced for impact. When the Corsair finally stopped, 3 feet from the carrier's island, the Navy's evaluation was immediate and brutal. This aircraft would never fly from carriers, ever. It was July 1942, and the United States had just declared its most advanced fighter aircraft a complete failure. But what those Navy evaluators didn't know in that moment of twisted metal and aviation fuel was that they were staring at the aircraft that would dominate the Pacific War. The fighter that would terrify Japanese pilots more than any other American plane. The bent-wing monster that would achieve an 11-to-1 kill ratio and revolutionize air combat design for the next 50 years. They'd just rejected the most lethal fighter aircraft of World War II, and it would take a desperate group of Marines to prove everyone wrong. The Corsair's problems started long before that disastrous carrier test. In 1938, the U.S. Navy issued a seemingly impossible challenge to American aircraft manufacturers. Build a fighter faster than anything flying, tougher than a tank, and able to operate from aircraft carriers. The specifications were absurd. Top speed over 400 miles per hour, range of 1,000 miles, 6 .50 caliber machine guns, and it had to land on a pitching carrier deck in the middle of the ocean. Most designers laughed. Vought Aircraft's lead engineer, Rex Beisel, didn't laugh. He calculated. The math was brutal and unforgiving. To reach 400 miles per hour, you needed the most powerful engine available, Pratt & Whitney's new R2800 Double Wasp, producing 2,000 horsepower. But that engine was enormous, requiring a 13-foot propeller to absorb all that power. Now the problem became geometric. A 13-foot propeller needed ground clearance. On a carrier-based fighter, landing gear had to be short to fit in cramped hangar decks. But short landing gear plus giant propeller equals propeller strike on every landing. The physics didn't work. Every conventional solution failed. Beisel's team spent 8 months wrestling with this impossible equation. Longer landing gear? Too heavy? Too weak? Wouldn't fit in the wing? Smaller propeller? Couldn't handle the engine's power. Smaller engine? Couldn't reach the required speed. The project was dying. Then, at 2 a.m. on a cold November night in 1939, Beisel sketched something that looked wrong. An inverted gull wing. Instead of angling up from the fuselage, the wing angled down sharply, then bent upward at the landing gear attachment point. It looked bizarre, unnatural, like a seagull's wing turned upside down. But it solved everything. The downward angle at the root gave the landing gear just enough extra length to clear that massive propeller, while keeping the gear short enough for carrier operations. The upward angle at the tips maintained aerodynamic efficiency. It was brilliant. It was ugly, and every aerodynamics expert who saw it said it would never fly. The wing joint where the bend occurred created massive structural stress. The airflow would separate and cause uncontrollable buffeting. The complex geometry would make manufacturing impossible. The Navy's own aerodynamics board rejected the design 3 times, but Beisel had run the numbers. The design would work. He staked his career on it. Vought gave him one chance, one prototype. The XF-4U-1 first flew on May 29, 1940. Test pilot Lyman Bullard climbed to 20,000 feet, then pushed the throttle to the firewall. The Corsair accelerated like nothing he'd ever flown. The airspeed indicator wound past 350, past 375, past 400. When Bullard finally leveled off, the Corsair was flying at 405 miles per hour, making it the first American fighter to exceed 400 miles per hour in level flight. Those impossible inverted gull wings flew perfectly. Zero buffeting, smooth as glass. The Navy ordered 584 aircraft immediately. Production began in 1942. That's when the real problem started. The Corsair was fast, brutally fast, but it was also a widowmaker. The cockpit sat far back on the fuselage, behind that massive engine. Forward visibility was almost zero. During the landing approach, pilots couldn't see the carrier deck at all. They were landing a 20,000-pound fighter blind, hoping they'd guessed the glide path correctly. The stall characteristics were vicious. Drop below landing speed, and the left wing would snap down without warning, flipping the aircraft inverted in an instant. Too low to recover, too sudden to survive. And that enormous engine torque? It created a rolling moment so violent that young pilots couldn't physically control it. At slow speeds, the Corsair wanted to roll inverted and die. Navy carrier qualification tests were a bloodbath of bent metal and terrified pilots. After 6 months of testing, the Navy's verdict was final. The F-4U Corsair was unsuitable for carrier operations. The Bureau of Aeronautics recommended canceling the program entirely. Vought had built the world's fastest, most powerful fighter, and the Navy didn't want it. The company faced bankruptcy. Engineers who'd worked 4 years on the project watched their creation get shelved. The Corsair seemed destined to become a footnote, a cautionary tale about overambitious design. Then, the Marines spoke up. The Marine Corps didn't operate from carriers. They flew from rough island airstrips, often carved out of jungle or coral by Seabees just days before. Land-based operations meant longer runways, no terrifying carrier approaches, and a desperate need for a fighter that could outperform the Japanese Zero. The Marines didn't care if the Corsair was difficult to land. They cared that it was fast, heavily armed, and could carry twice the bomb load of anything else flying. In February 1943, Marine Fighting Squadron 124, the Checkerboards, arrived on Guadalcanal with the first operational Corsairs. Their commander, Major William Geese, gathered his pilots and told them the truth. This aircraft will try to kill you every time you fly it. Respect it, master it, or die. Learn its quirks, or don't come back. The Marines developed techniques the Navy had dismissed as impossible. They flew curved approaches that kept the runway visible until the last moment. They added power throughout the landing to counter the vicious stall. They treated the Corsair like a 2,000-horsepower Tiger that could be ridden but never tamed. On February 14, 1943, the Corsairs got their first chance to prove themselves. A formation of Japanese bombers and Zero escorts approached Guadalcanal, expecting to find the usual American fighters, P-42s and P-39s they'd been dominating for months. Instead, they met 12 Corsairs at 25,000 feet. What happened next shocked both sides. The Corsairs dove from altitude, accelerating past 450 miles per hour, a speed the Zeros couldn't match in their wildest dreams. The Japanese pilots tried their standard defensive maneuver, a tight climbing turn that usually forced American fighters to overshoot. The Corsairs didn't overshoot. They followed the Zeros through every turn, their massive engines and strong airframes handling G-forces that would have torn apart lighter aircraft. The 6 50-caliber Browning machine guns, each loaded with 400 rounds, created a cone of destruction that shredded the nimble but lightly built Zeros. In 8 minutes, the Corsairs shot down 7 Japanese aircraft without losing a single plane. It wasn't even close. Japanese pilots radioed back in disbelief. They called the Corsair "whistling death" because of the distinctive sound the air made passing through the wing root oil coolers at high speed. That whistle became the most feared sound in the Pacific. Word spread through the Japanese Air Forces. Avoid the bent-wing fighters. They were faster, stronger, more heavily armed, and flown by pilots who'd mastered a machine that should have been impossible to fly. Over the next 2 years, Marine Corsair squadrons carved through Japanese aviation like a chainsaw through paper. The numbers became almost absurd. By the end of the war, Corsairs had shot down 2,140 Japanese aircraft, while losing only 189 of their own, an 11-to-1 kill ratio, the highest of any American fighter in the war. But the kill ratio only tells part of the story. The Corsair revolutionized ground attack tactics. Its rugged construction and powerful engine meant it could carry 4,000 pounds of bombs, or 8 rockets, more than many dedicated bombers. Marine pilots discovered they could dive bomb with precision, then strafe with those 6 machine guns, and still have enough speed and power to escape ground fire. The Corsair became a complete weapons system: air superiority fighter, dive bomber, ground attack aircraft, and close air support platform all in one airframe. At Okinawa, Corsairs flew 64% of all Marine combat sorties. They destroyed hundreds of Japanese aircraft on the ground, shattered defensive positions, and provided constant cover for Marines fighting through the bloodiest island battle of the war. Pilots flew 4, sometimes 5 missions per day. The aircraft took staggering damage, limping back to base with holes you could crawl through, severed control cables, and engines leaking oil and fuel. And they kept flying. Then something unexpected happened. By late 1944, the Navy was watching Marine Corsair squadrons dominate the Pacific, while their own carrier-based F-6F Hellcats, excellent fighters in their own right, couldn't quite match the Corsair's performance. The Bureau of Aeronautics quietly reopened the carrier qualification program. New pilots, trained specifically for the Corsair's quirks, modified aircraft with raised cockpits for better visibility, refined landing procedures based on 2 years of Marine experience. In April 1945, 30 months after declaring the Corsair unsuitable for carriers, the Navy finally cleared it for carrier operations. The fighter they'd rejected was coming home. Navy Corsair squadrons joined the war in its final months, flying from the same carriers that had once deemed the aircraft too dangerous. They vindicated Beisel's revolutionary design completely. After the war ended, the Corsair continued flying long after its contemporaries were scrapped. The Navy kept Corsairs in frontline service until 1953, flying combat missions in Korea. Some military forces operated Corsairs into the 1,960 seconds, 20 years after that first disastrous carrier landing. The bent-wing fighter outlived the war it was designed for, and the generation of aircraft that came after it. But the Corsair's real legacy lives in every modern fighter jet you see today. That inverted gull wing taught engineers that unconventional solutions often solve impossible problems. The Corsair's brutal power-to-weight ratio established the template for energy fighters that dominate through speed and climb rate rather than maneuverability. Its multi-role capability, carrying both air-to-air and air-to-ground weapons with equal effectiveness, became the standard for every fighter developed since. The F-15, F-16, F-18, F-22, and F-35 all carry the Corsair's DNA. Overwhelming power, rugged construction, technological innovation, and the understanding that the best fighter is the one that does everything well. Rex Beisel, the engineer who sketched that strange bent wing at 2 a.m., lived to see his rejected design become legendary. He watched Marine pilots who'd cursed his aircraft's difficulty turn around and call it the finest fighter they ever flew. He saw test pilots who'd written scathing rejection reports quietly admit they'd been wrong. He witnessed his impossible aircraft achieve combat records that would never be matched. When Beisel died in 1972, the Navy sent a Corsair to fly over his funeral. That bent-wing fighter, the one everyone said would never work, the death trap that almost bankrupted his company. The aircraft, the Navy rejected, and the Marines mastered. It roared overhead at 400 miles per hour, exactly as Beisel had promised 32 years earlier. The Corsair proved something that echoes through aviation history. Sometimes the experts are wrong. Sometimes the impossible just requires someone brave enough, or stubborn enough, or desperate enough to make it work. That Navy evaluator standing on the deck of USS Shangri-La in July 1942, watching Porter's crashed Corsair trailing smoke, he was staring at the future of air combat. He just didn't know it yet. Because the best fighter aircraft of World War II wasn't the one that landed easily. It was the one that, once mastered, could do everything better than anything else in the sky. The Marines understood that, and 2,140 Japanese pilots learned it the hard way.